All right, I'm just going to get started here.
I don't know.
I'm going to get started here with your new homework assignment.
Service Pack 2 is all right.
Some of you, or most of you, should feel that this homework assignment is just boring and mostly chore. Okay, that would be the right, feeling about this homework assignment as you're doing it, because it's really just kind of long, but it doesn't have any new things or even new challenges compared to all the other things that we have talked about. All right, so we'll take a look at the homework assignment. I just want to point out what you need to do, and then we'll move forward to talk about new concepts. So here it is. This is your new homework assignment. It is about subroutines. The local variables that we'll talk about today is not in this homework assignment. So actually, since Tuesday, you already understand all the concepts that you need to do this homework assignment. We'll just take a quick look here. We have two subroutines. The first subroutine is F1, it increments the value of x. The second one is F2. It invokes F1, and then it adds 10 to the value of x, and then it invokes F1 again. And then outside of the subroutine definitions, we have the initialization of x, the invocation of F2, and then the invocation of F1. So, as I said, it doesn't really use any new concepts, doesn't even have recursion in it. Okay, there are no subroutine here calling itself, so it should be fairly straightforward. It's just kind of tedious because you have to allocate the column, deallocate the column, allocate it again, and deallocate it again. It's just mostly just chore. But it is a good exercise so that you can kind of practice how to invoke a subroutine and also what to do at the end of a subroutine. So you have to know where to go back to. So that's really the intention of this homework assignment, is to reinforce concepts that we talked about on Tuesday. Are there any questions about this homework assignment? No questions? Okay. So without any homework questions about the homework assignment, and sheet 2 already has a beginning point, which is really insignificant. The traits will get a little bit long, so you might need to use this feature to drag this bar down, so you can separate the screen into two portions, and each portion has its own little scroll bar. I'm not sure how big your screen is, so you may not even need to do that. Or if you have used a smaller font, that also helps to kind of to fit more stuff on the screen. Can you turn it into a portrait mode?
Yeah.
Your 42-inch TV?
I can, but it's pain. Big pain.
Big pain. That would make a very nice, vertical.
HP made a TV, or it was a monitor, but it might as well have been a TV that actually had a.
There's no difference.
You hit a button and it would spin. I think it was 32-inch though.
There's no difference between a monitor and a TV these days, and no difference between a computer and a TV either. No. Most TVs, now come with what? Netflix and Hulu. Some are Android powered. So they're really just computers. They're basically monitors with a built-in computer.
I have a Roku, a smart TV, and a Blu-ray player all plugged into my TV, so it's like two computers right there.
Yep. All right, so we are moving on to local variables and parameters today, okay, which is a very big and very important topic, because what we have done up to this point, all of our variables are what we call global variables, okay? And you will hear me say this again and again, global variables are evil. Okay? In other words, if you write your program in the next class in C++ and all your other classes, every time you use a global variable, you really have to think hard and say, okay, does this really have to be a global variable? Okay, and you will find, well, hopefully you will find that in most cases, you can avoid the use of global variables by using parameters instead. Okay? Global variables are evil in many ways. Okay? They're evil in a way because they can make your program difficult to maintain. A lot of things can make your programs difficult to maintain. Global variables are particularly evil because it offers short-term convenience. So a lot of times you need to make some quick changes to your program, and global variables is a very easy way to let one part of your program to communicate with another part of your program, because it doesn't involve the change of, we'll talk about this, parameters. It doesn't need to change. It doesn't involve the change of the protocol of a subroutine, which we'll also deal with later. In other words, okay, this is the deal. Okay, global variables offers convenience, but at a price of downstream maintenance nightmare. When I say nightmare, most of you will not experience the nightmare until you get out to industry for a few years. Because the worst programs, or the longest, the most complex programs you have to write here at AR, or even a four-year university, even Berkeley, okay? If you go to Berkeley, I will bet you the most difficult program project that you have to deal with may have several thousands of lines, which is nothing. Okay, that's considered nothing compared to what you have to deal with in industry. Because how long do you think it will take you to write that several thousand line program? Maybe one semester, maybe two, maybe three. They might have classes that span over several semesters, but that's it. Okay, maybe up to a year. So the maintenance of that program will only last about a year. No big deal. And who else is going to write that program? Supposedly nobody else, right? It is your project. You're not supposed to share the project with somebody else. But when you work in industry, everything changes. What is the order of magnitude in terms of number of lines in industry? Depending on the project, but let's just pick a typical project, let's say the GIMP, okay, which is a kind of Photoshop type of program. We're talking about millions, okay? Almost every single case is in at least hundreds of thousands of lines. So I'll just go ahead and take a look, the GIMP source code. Okay, the GIMP from source, no, I just want the statistics. Maybe I should say number of lines. Yeah, it doesn't have that. It doesn't give me the number of lines of code in the GIMP. Sorry?
Should say on the source code page.
All right, we'll take a look. The source code page, would usually just
Yeah, there's a jump to give source code.
Yeah, but it doesn't give you the summary of the lines of code. It gives you it gives you a method to download the source code, but it doesn't automatically give you the number of lines. I just need to get a rough number, and it doesn't have it. Yeah, wiki is the other. Okay, it probably doesn't contain that number either. Nope. No, it doesn't contain that. But it's at least thousands of hundreds of thousands of lines.
700,000.
Where?
700,000.
700,000?
Yeah.
Okay, 700,000 of lines of code, and can anyone kind of imagine how long it took to get up to this point? The history of the code, and how many people got involved in the programming of the GIMP? A lot of people. Okay, it's an open source project. So when you deal with a project of this magnitude, the use of global variables will have a lot of impact. Much more so when you have a project that spans over 2 or 3 semesters and only has 5,000 lines of code. Okay, so it is when you have to deal with a project like this, and somebody else has been using global variables a lot to as a convenience, and you are the one who has to fix problems, then you will go back and say, man, I wish that person did not use these global variables just for convenience, because now it's hard for me to track down things. So we'll talk about why global variables are so evil, even though it is convenient. Why is it a bad thing to do when you organize a program? But for now, we'll just go ahead and focus on local variables and parameters. This is all linked from the class notes here. So I'm not going to really read the class notes. What I'll do instead is to point out where you can find the notes so you can read it yourself, and then we'll just go ahead and talk about what is the problem of global variables and why local variables are useful. So we'll go ahead and look at an example. It's very hands-on. So we'll go ahead and write a program that uses global variables, but it is a bad program because of because of that reason. So define sub, I'll just call that x2 for times 2. We'll go ahead and write a loop here. So we'll do our usual loop. Okay, I have to configure my autocorrect again and turn off certain things. Use replacement table, and I don't want I to be replaced. Nope, it's now customized. Okay, I gets the value of 0, while I is less than 2. Oops. Do. And we have another variable called x. X gets x plus 1, and while, and define sub. And we'll define another subroutine called x4, which means multiply by 4, or add 4, I should say, add 4 and add 2. Fine. Switch. There we go. Okay. Now, since we have a subroutine called add 2, I'm just going to leverage that. And I would say, in this case, to add 4 is to add 2 twice. So here I just have to invoke add 2. I guess I plus 1, which I'm missing on the other one too. So I will reinsert that one. Okay. Plus 1 and define sub. X gets an initial value of, it doesn't matter. We'll start with 3. Invoke add 4. So by the time I get back into the main program, X should have a value of 7. And let me fix the indentation. I think by now all of you understand the importance of indentation, because without indentation, these programs are a little bit harder to read. I wouldn't say it's not possible, it's just a lot harder. There we go. And here's a question. What do you think indentations mean to a C compiler or C++ compiler? Because most of you are moving on to cisp300, so you'll be using C and C++. So what do you think indentations mean to the C++ compiler? Absolutely nothing. A space, a carriage return, tabs, a sequence of spaces, they all mean the same thing to the C compiler. What? Wait, hold on a second here. Did I just say, line feed, which is in a new line, means the same thing as a space? Yeah, I did say that. So that means, this entire program, if you want to do it in C, you can type this entire program on a single line, and it still means the same thing. Does it mean the same thing to you? Okay. Ultimately, it has the same meaning. So the interpretation takes a little bit longer to find the beginning and the end of the constructs. Very good. So in this class, we'll try to have a good habit of indenting using the correct indentation for the programs. What is worse than no indentation?
Incorrect indentation.
Absolutely, you just got it. Incorrect indentation, gives people the wrong sense of nesting. So that's actually worse than no indentation, where people have to say, okay, I better make sure the indentation is good. Because if you give people the wrong indentation, then people may think the program is structured one way, but it's actually structured another way. All right. So let's go ahead and take a look at this program. Now, are there any questions about this, about add2? Add2 seems to be okay by itself. Okay, I have a counter called I. As long as I is less than 2, I want to add 1 to x and add 1 to I also, because I is used as a counter, but what I really want to do is to add 2 to x. And while, so it should go through, x gets x plus 1 twice, because the loop should only, go through the, it should only have 2 repetitions. Add 4 by itself seems to be fine too, because if we make the assumption that add 2 works the way it's supposed to, then invoking add2 twice should add 4 to x. So as a result, the subroutine add4 should add a value of 4 to x. Okay, so that seems to work too. I mean, it seems to make sense. So when we trace it, we'll find out that, it doesn't really quite work that way. So we'll go to line number. We have I as a counter and x as a variable that we want to increment. As a precondition, we can say we don't know anything about either one because we are going to initialize these variables as we use them. Then the first line to start with, we have to start with line 15 because it's the first line outside of the definition of a subroutine. It initializes x to 3, doesn't do anything to I because we will initialize I inside the subroutines. Then we move on to line 16. Line 16 is an invocation of add4. So when we invoke a subroutine, we have two things to do. Allocate the leftmost available column, in this case it's column E, and use it to remember where we're supposed to go back to when add4 finishes. In this case, we're returning to post because line 16 is the very last line of the program. So when invoke add4 is done, we are actually done. There's nothing else to do. The second step of invoking is to going to the subroutine starting on the first line in the definition of the subroutine. We're invoking add4. The first line is line 9. Line 9 doesn't do a whole lot of exciting stuff. All it's doing is to initialize the value of I to 0. Line 10, pretty standard, boring stuff that we have done many times. I has a value of 0. 0 is less than 2 is true. We go to the next line, which is line 11. It invokes another subroutine. It invokes add2. We know how to deal with that. When you invoke a subroutine, you allocate the leftmost available column. In this case, it's column F because column E is in use. You use that column to remember where to go back to. Invoke add2 is on line 11, so when we come back, we should continue with line 12. Okay, so that's pretty easy. Since we're invoking add2, we have to start with the first line in the definition of add2, which is line 2. Line 2 is going to initialize I to 0. Now, some of you, or many of you, will start to understand the problem right now because this is the very same counter that we were using with add4. Okay, we are reinitializing the same counter, even though it is to the same value. It should really raise a red flag in your mind right now and say, wait, I thought this variable was used by add4, and now add2 is going to use the same variable. Okay, so you should have a little bit of doubt right now and say, okay, I think we have a little bit of a problem here, even though it's not evident at this point because we are just reinitializing I to the same value, which is 0. So we move on to line 3. Line 3 is fairly simple. I is less than 2 is true because I still has a value of 0. Line 4 adds 1 to x. X goes from 3 to 4. Line 5 adds 1 to I. I goes from 0 to 1. I think we have a problem because I is supposed to be 0 from add4's perspective, and now it is changed to 1. But let's go ahead and finish this trace so that we can actually see what is happening with this program. I is 1, 1 is less than 2 is true, so we get out, we stay in the loop, we go back to line 4, add 1 to x, x goes from 4 to 5. We go to line 5, we add 1 to I goes from 1 to 2. We go back to line 3, I has a value of 2 now, so I is less than 2 is actually false. When we get out of the loop, we go to line 7. Line 7 is the end of a subroutine. We look up the rightmost return line number. It tells us to continue execution on line 12. That's the first step of returning from a subroutine. The second step is to indicate this column is no longer in use. We use a strike through to indicate this column is now deallocated, is no longer in use. We now continue execution on line 12. Line 12 is right here. It's going to add 1 to I. Oh, I think we have a problem because I, instead of being 0, is now 2 already, but we're going to add 1 to it. It becomes 3. So this time, by the time we get back to the beginning of the loop, which is on line 10, I is less than 2 is false already. And we have no choice but to get out of the while loop. We end up on line 14. We do the usual return thing. Look at the return line number, which is post, and deallocate the column. The subroutine itself is not the problem. It is the use of I in both subroutines that is the problem. Because x is supposed to end up with a value of 7, and we got out too early. It's because, quote unquote, the I variable of add4 is also the I variable of add2. So when add2 changes the value of I, by the time we get back to add4, it's already changed. There's no way for me to remember what it used to be and continue the loop in add4. Are we doing okay? You know, understanding the problem with this logic? No food, sorry. I know it was Halloween yesterday, but you know. But are we doing okay with this particular program?
So I is the global variable.
Because I is a global variable, there's only one variable I, and it's being used by 2 subroutines. The problem in this case is when you look at this code add2 in this block of code, and you look at this block of code, it gives you the false sense that each one has its own variable I. Because it seems okay, because this seems to be, when we look at I in add4, it gives us the false sense that, oh, this is variable I of add4. When we look at add2, it gives us the false sense of security by saying, oh, this is the variable I of add2, but that's not the case. There's only one global variable I, and it's being shared. Yep.
So, I mean, I guess because I have a little outside experience, it just seems kind of different. But I know for a fact once I pass that I variable into the function that I'm calling, that it's still gonna be local to the function that I came from.
It's not local. There's nothing is local at this point.
Well, that's what I'm saying. Like you're saying, like it's global.
Mm-hmm.
But in this instance, let's say my invoke add4 in line 16. I'm going to add 4. Okay, I is initialized to 0. And then obviously that's less than 2, so I'm going to move into that block. I'm going to invoke add2, but you're not going to pass.
There's nothing passing
I
here.
that's in.
There's nothing being passed.
But that's what I'm saying. So how is it seeing I as a different value than like what you're saying? Like how is it seeing I outside of what it is in that function itself?
Well, we don't have we have not talked about the mechanism so that each subroutine has its own I. So the main point is just that, is that they're sharing the same I. So when we went back, when we do the return, which is row 18 of the trace, when we went back from add2 to add4, the value of I is continued because it is the same variable I. That's the source of our problem. And you had okay. So this is the problem. Okay, I can use an analogy to illustrate it. It's like, let's say, my car has a CD player, okay?
I mean, I understand like
Okay, go ahead.
scope. I understand like scope.
But we no, scope. Okay, I think you're thinking ahead of the class. Because right now, all we're doing is we're using global variable. There's only one. So that's why we need the concept of a local variable. So that's good. I think you're a little bit ahead of the class. Go ahead.
Aren't global variables defined outside the subroutine?
In this type of pseudocode, if it's not explicitly defined as a local variable, it is global. So I didn't make that clear.
I think that's
I
what
think that was the
confused me
reason.
because like I know it can't like like for instance invoke add2.
Mm-hmm.
It's not gonna see the I that was in defined for like an actual language because you have to pass that value into that function for it to see that I. It said I.
Okay, you're thinking ahead of us.
Alright, I'll stop.
Okay, Just give me a little bit of time so I can finish that. Okay. Sorry, no drink either.
Can we just point out there's no sign? There's no sign.
Oh, there's no sign. They removed the sign. Oh, it's back there because they changed the orientation of the classroom. Okay, I will ask them to put the sign up front instead. Sorry about that. I didn't know, you guys did not know because the sign is back there. But it was in the syllabus too. All right. Okay, so getting back here, if you already have exposure to programming languages and you already understand what a local variable is, I just have to make it extra clear that in my type of pseudocode, if I don't make a declaration that something is local, it is automatically a global. Is that okay? So in this case, X is automatically a global, and so is I, even though I was not used at all outside of the context of a subroutine, because I did not say it is a local, it is automatically a global. And that convention is actually shared by a few programming languages like PHP and Perl. They both would automatically make a variable global if you just start to use it out of nowhere. All right. So how do we fix this program?
You make local variables.
We make local variables. Very good. So let me save this program first, and I will save it into today's folder. And I have to make a new folder name for that too. Sorry?
That what causes memory leaks? We have a program that starts to just...
No, there's no memory leak here. It's not dynamically allocated, so you're fine. Oh, I just saved it as untitled one. Sorry. Okay. I'm going to save the new program as local. Okay, local, which means I'm starting to use local variable. The syntactical change to the program is really minor. This is how I'm going to change the program syntactically. I'm just going to insert a row here to say, guess what? I have a local variable I. And I will do the same thing here. Technically, I only need one place to have a local variable I, but in practice, it's better to use both. Oops, wrong direction. And renumber the lines, just like that. But before we go any further, I want to go back to the other program. Maybe it's still up. Nope, it's not. Let me open it again. I want to open this program again, and someone, without understanding of any local variable can still give me a suggestion and a really easy way to fix this program. Why am I so stuck with I? Change it to J in one of the subroutines, right? That's an easy fix. Pick one of them. Okay, pick sub2 or sub4, or add 2 and F, or add 4. Change all the references to I here to J, and the program is gone. Right? That's an easy fix. What if you have 500 subroutines?
There's only 26.
How can you be sure that I or J or K or whatever name you pick is not used in another subroutine? I have an answer to that too. See, I'm a smart ass. I would just append the name of the variable to the name of the subroutine. So in this case, it will be add underscore I. In the other case, we add 2 underscore I and add 4 underscore I. That's an easy fix. Now it is. Now the variable names are guaranteed to be unique within. It can only be used inside the subroutine. What if I had a typo? What? No, that's not the case. If I had a typo in another way, okay, once we switch to local variable, we'll talk about the typo problem, okay? Because if I have a typo problem with a local variable, the compiler will complain and say, hey, there's no such variable. I cannot mistakenly use somebody else's variable when I use local variable. That is the difference, okay? Okay. So the point is, even though I can have a naming convention to make sure that the variables are unique, I can have a little typo when I write the code or when I copy and paste and forget to change one of the names. Then I can accidentally have one subroutine to use a variable intended for another subroutine and end up with the same type of problem. Okay? So are there any other questions, any other suggestions of fixing this without using local variables?
Arrays.
Arrays. Now, how do you fix this using arrays?
Make an array and then the subscript, whatever.
Okay, but what if you type a typo with the wrong subscript?
I understand that.
Yep.
So it's
And also, without the use of local variables, recursions get a little bit tedious. Okay, so we'll talk about why local variables have something to do with making recursive algorithms easier to express. Okay. Any questions from you guys? Any questions that I can answer? Nope? Okay. Sorry?
Well, you said we can't have
Oh. Yeah, well, it's written back there too. You want coffee? I want coffee too. After the class. All right. You can have plain water. I mean, if you have plain water, you can drink it in the classroom. It's just not anything sugary. Yeah, you still have another 15 minutes before you can get your caffeine fix. Yeah, that's also applies to me too. Most students don't want me to be. Most students do not want me to be caffeinated. I don't know why. All right, so let's take a look at this new program. Syntactically, it's almost the same as the other one, but in terms of the execution, it's very different. So we'll go ahead and take a look at this program as we run it. All right, so the line numbers have shifted a little bit because we added 2 lines, which doesn't seem to be important. Before we talk about anything else, let's go ahead and just look at this program, but in a static way without actually tracing or running the program. When I declare that I is a local variable, it means, in terms of the scope, it is local. So this means, I is this particular variable I is only visible from line 2 to line 7. There's no other way anywhere else in the program to refer to this particular variable I. Okay? So in other words, local has a sense of being, it's local in terms of scope. In the other case, when we look at this local I in the context of the subroutine add4, it's the same thing. This variable I is only accessible from line 10 all the way to line 15. Nowhere else in the program can refer to this variable I.
So when you use add2 within add4, doesn't that mean that your local, you can access this outer local within the inner
Nope,
one?
because because the scope applies to, see, when I'm on line 12, I have visibility to this I,
Sorry.
but I have no visibility to the other I.
But when you're in the inner one,
Okay, so
you're
if
still
I'm,
within the scope of the outer one.
no,
because
it's
you're
not,
within-
not statically. Okay, if I'm on line 4 and I want to compare I to 2, that means I'm inside the scope of add2, and that's why I'm out of the scope of add4 already. Scope refers to, in terms of the lines, in terms of the text of the program, it is, whatever is surrounding this line that you're executing. So it depends on where you are in execution. It doesn't depend on who calls you. But that was a very good question. Okay, so when we run this program, it behaves, differently. Okay, the first part is the same. Line 17 is the first line of the program, and x gets a value of 3. Line 18 is doing the invocation, and right here we have a change. Okay, we have the same thing as last time. We have to remember, where to get back to. So we still have a return line number, and it is still post just like last time because there are no additional lines after line 18. But you know what? We need one more columns now. Local variables also live on dynamically allocated columns. So now, for every local variable, I need to allocate a column. In this case, column F is the first column on the right-hand side that is not allocated. I'm going to use it for local variable I of add4. Yep.
So if all the variables of I are local, would you even have column C?
Good point. I should have removed that too. Thank you. So this should be removed because I don't have a global variable I anymore. Thank you. Forgot about that. Okay. So that's the change. Yep.
So each I is going to have its own value within each function.
It has its own column.
Alright, so there's going to be like...
There will be two
different
columns
values. Yeah.
that are both called I, but because of the scope control or the scope limitation, I can only see one I at a time. Okay. So let's go ahead and continue with this program, but this is new. Okay, this is something new. You know, we have not done anything like this before, but we are allocating a new column to make space. You know, to create the space for a variable on the fly. When we get into the subroutine add4 on line 11, line 10 we don't trace because it doesn't really do anything. We are now initializing column E to 0. When we go to line 12, we're comparing column E to 2. I is 0, 0 is less than 2 is true. So this part is pretty much the same. We go to line 13, we go through the usual motion of reserving a new column to remember where to go back to. In this case, we have to return to line 14. But we also have to remember to allocate for the local variable I in subroutine add2. So now we have another column allocated for another variable, local variable I, and it also starts with an unknown value. That part is important. Every local variable should start with an unknown value. Okay? And this is extremely, extremely important because the C compiler, unless you turn on certain switches, does not complain about uninitialized variables. In other words, if you forget to initialize a variable and start using it, it doesn't generate any complaints or error messages or warnings. You have to turn on the switch or specify, I think it's -WALL, warn all, in order for the compiler to say, hey, I think you might have a problem here. You're starting to use a variable before you initialize it. Okay, but unless you turn on that switch, it doesn't give you any complaints. All right, so after we invoke add2, we continue execution on line 3, which is initializing I to 0. Now, because we are now executing line 3, the scope tells us that we are using variable I of add2, and so the initialization will only affect column G and not column E. That is very important. Are we doing okay so far with these concepts? Local variables have two attributes, not one. The first attribute is the scope, which means, you know, where can I see a particular variable is localized to the block that contains its definition. So it is local in terms of scope. The second attribute of a local variable is it doesn't even exist until the subroutine containing it has been called. So even its existence is localized. Okay, it's temporary. It only exists for as long as the subroutine is active. Are we doing okay so far with both of those concepts? Okay. So after line 3, you know, we go to line 4. The rest of the program is actually quite boring. Okay, so we have I is less than 2 is true. We go to line 5. X is still global, so we have to, you know, increment the global variable x. Column C gets to 4. We go to line 6. Once again, line 6 is inside the definition of add2, so that's why we are it can only see local variable I of add2. It is not even aware of variable I of add4. There's no way to confuse the two I's. Are we doing okay so far with those concepts?
So are you always going to refer to the rightmost I variable?
In a trace, yes. In a trace, that's basically the rule. We can only see the latest variables that we have defined. That is correct.
If you have recursion, so you're invoking add4 within add4,
Yep.
you create a new local variable each time you use
Yep,
something.
you do. Yep.
So in other words, to look at it, is that local variable I is the subroutine itself, even though it goes into a different subroutine within that subroutine.
Correct. The scope of a local variable means it is only visible when you're executing code inside that subroutine. So at this point, because I'm executing line 6 is inside add2. It has visibility of the local variable I of add2, but it has no visibility. Even though the variable is still there, it is still existing, I have no access from line 6 to the local variable of add4. It's just not visible whatsoever. It's kind of, okay, if you want an analogy, it's kind of like this, okay? You have cubicles inside the office environment. So the Post-its and all the items, next to the water bottle and the copier, those are the global variable. Anyone who walks, up to the copier has access to all the little Post-its and whatnot, next to the copier. Local variables are Post-its inside the cubicles. So unless you are inside a particular cubicle, you are not even aware of what type of Post-its and little notes are available inside the cubicle. So that's why it has the scope is limited to only within the cubicle. What is difficult to explain using an analogy is the Post-its don't even exist until somebody is in the office doing work. So an empty office with nobody doing any work has nothing. It doesn't use up any resources. You guys doing okay? Okay. All right, so line 6 is going to add 1 to I, but once again, because line 6 is inside the definition of add2, it only has visibility of I of add2, which turns out to be column G. So column G is the only one that is incremented to 1, and that's why we don't have a problem in this case, because column E and column G are now 2 independent columns. Changing one doesn't affect the other one whatsoever. So after this, I will just go ahead and kind of fast forward a little bit, because the rest is a little bit boring. So I'm just not going to explain much until we get to the next interesting point. It is false now. Then we get to line 8, which is the end of the subroutine. Now this part, I think most of you probably already know it or suspect this is going to happen. The first thing that we have to do is still look up the rightmost return line number, which is column F. Column F is still telling us to continue execution on line 14, so this behavior has not changed. However, when we deallocate columns, now we have 2 columns to deallocate. In other words, whatever you allocate at the beginning of a subroutine, you have to deallocate when the subroutine is done. So this is the other aspect of a local variable. It only starts to exist when the subroutine is invoked, and it stops its existence at the end of the execution of that subroutine. Are we doing okay so far with the dynamic behavior of a local variable? Okay, you create it when the subroutine is invoked. You also have to deallocate it when the subroutine is done. Okay, so the rest of the program is really kind of boring because I'm going to do this again, but copying and paste works this time. Okay, we are getting back to line 14. Line 14 has to increment I, but because line 14 is inside the scope of add4, that means line 14 only has access to the variable I of add4, which is column E. So column E is now incremented to 1. Then we go back to line 12. I is less than 2 is true. And then we go to line 13 again. But this time, I can safely copy and paste the code. The reason why I can now safely copy and paste the code is nothing within this execution. Well, I guess I have to modify these. So this will go to 6 and 7. But as far as I is concerned, the local variable I of add4 is not getting changed until we get back to line 14. So we have to change this one to 2. and then we go to line 12 again at the beginning of the loop. I is less than 2 is, let's see, should be false this time because this is our second time already. And then we get all the way out to line 16. And once again, we have to look up what is our return line number. It is post. So that means the next line we execute is post. But we also have to remember to deallocate both of those columns when we do the return. Oops, wrong line. Undo. Okay, there we go. And that's the trace of a program with local variables. Yep.
I was kind of curious on that. What would happen if you were to invoke add2 within itself with a local variable?
Well, that's what he said. That's what he asked too. Is when we have recursive subroutines, what happens when we have local variables. So we'll go ahead and take a look at that. I'll just pass the row sheet around. All right. So this is our first encounter with a local variable, and we'll go ahead and write a new subroutine that we are already somewhat familiar with. It is called recursion, the recursive version of factorial. So define sub f for factorial. And this time we have a local variable. Okay, we call this local variable, I don't know, just call it x. Before we do anything, x gets the value of n, and then we say if x is greater than 0, then we do the recursive call. And before we do the recursive call, we have to say n gets n minus 1, invoke f, and then the result is r gets r times x. Else r gets a value of 1, and if, and define sub, and we'll go ahead and say, let's say we want to compute the factorial of 2. Well, let's make it 3 because 2 is not interesting. 3 is the first one that gets a little bit interesting. Invoke f. Fix the indentation. So give it a, save it first. Now you will see factorial reinventing itself or re-implemented several times, because every time we introduce a new concept, we'll re-implement factorial using that new concept. So we'll be refining factorial as we go in this class, just to use better concepts along the way. Right. So now we have a local variable x, and it is a recursive subroutine because the subroutine calls itself. And we'll go ahead and trace it. I can just switch the two windows so we can use the other one for tracing. Okay, there we go. We need comments in this case because we do have conditions to evaluate. There are two global variables in this case. We have n as a global variable, and so is r, that's also a global variable. The last revision of factorial will end up with no global variables whatsoever. Okay, so we will have enough mechanisms to get rid of global variables altogether, at least in the context of factorial. Okay. So when we trace the program, we start on with pre. The precondition is we don't need to know anything about n or r because they will be initialized before they get used. On line 13, we invoke subroutine f. So we have to do the usual thing. Return line number is post. Oops.
No, line 12.
Oh, line 12. Sorry. Jumping ahead.
That's the way it's 2.
Okay. Line 12 initializes n to 3, and then we get to line 13. We allocate a column for return line number. It goes back to post. But we also have to allocate one additional column for our local variable. The local variable in this case is x, and local variables always start with unknown values. This means when we have homework assignments involving the use of local variables, if you don't indicate they start with an unknown value, I will take points off, because it is a very important part of programming that you have to remember. Because if you forget about that thing, if you forget that local variables have unknown values to begin with, you can end up with programs that works most of the time. Which is the worst thing you can get. If you have a program that fails consistently, and every time it fails exactly the same way, it's a good thing. If you have a program that works most of the time, and every time it fails in a different way, it's not good. Okay? And a lot of times, programs can fail unpredictably because of the use of uninitialized local variables. Global variables, not as much of a problem, but local variables, definitely a bad problem if you don't initialize them. Okay, so getting back to the trace of the program, now we can get into the first line of the subroutine, which is on line 3. Line 3 is basically remembering what n is before we go any further in the algorithm. So we copy the value of n, which is a global variable, has a value of 3 at this point, to my local variable x, okay, just like that. Then we go to line 4, we evaluate the condition. That is true. We go to line 5. Line 5 changes the global variable from 3 to 2. Line 6 is going to invoke again. When it invokes again, we can kind of copy and paste a little bit, but the return line number has to change to line 7. All right. Are there any questions at this point? Which line am I on? We're on line 6 right now, right? So, okay, we're on line 6, and then where are we going next?
3.
We're going back to line 3, exactly, and then we have to remember the value of n in x again. This time, which column am I going to change?
H.
We're going to change column H. We're changing column H because column H is the most recent definition of the local variable x. Okay, so even though we only have one scope, there's only one scope in this case because we only have one subroutine. But the scope in this case doesn't tell you which column we should use because both column F and column H are local variables x in the subroutine factorial. Okay, sub F, subroutine F. So in that case, you have to use the most recent definition and not the old definition. In fact, when we are on line 3 right now, we only have visibility of column H. We don't have visibility of column F anymore. Because local variables are not only local in terms of scope, they're also local in terms of invocation. We have 2 invocations of column F at this point. Only the current invocation has visibility of the variables. So that's why when we change x, we always only change column H in this case. After line 3, we go to line 4. X is greater than 0 is true. We go to line 5. N is decremented to 1. We go to line 6. We do the same thing here. So I'm going to split both horizontally and also vertically. It's kind of cool that we can do it like this. All right, so we are now on line 6. We're invoking the subroutine. I have to remember which column I have not used yet. Okay, so there we go. So return line number is line 7. And then we allocate one additional column for x. And x is a local variable. It always starts with an unknown value. We'll have to allocate one more time, because that's one more recursion. Maybe not. This is one. Yeah, we have one more level. After line 6, the invoke, we start from the beginning of the subroutine. So that means we're going back to line 3. On line 3, we copy the value of n, column C, which is 1, to local variable x. So x now has a value of 1. Then we go to line 4, reevaluate the condition. It is still true that x is greater than 0. We go to line 5, we decrement n to 0. Then we go to line 6, we do another invocation. And you can see how it is useful to be able to split the screen into like 4 portions this time. Yep.
If we're doing a trace like for homework, could we do things like color code the columns or anything?
Yeah, you can.
Okay.
You can add additional, visual effects, to make it easier. This one I should not copy. So we are getting back to line 3. Line 3 is going to copy n to x again. N is column C. It has a value of 0 this time. We copy that. And then we go to line 4. X is greater than 0. It's false this time. So when it is false, where do we go? We go to line. Yeah. We go to line. Okay, this is line 4. Line 4 is the beginning of a conditional statement. The condition is false. Where do we go?
Else.
Huh?
9.
9, exactly, very good. We go to line 9, we go to the else of the conditional statement, and here we initialize the global variable r, so it starts with a value of 1. And then we get out of the conditional statement, we get to line 11. Line 11 has 2 tasks to perform. The first one is to look up the return line number, the rightmost one. It tells us to go back to line 7. And then the second thing it has to do is to deallocate both of these columns. So those columns are now deallocated. We are now back onto line 7. Line 7 says I want to compute the product of r and x. Okay, which r and which x are we talking about? Which 2 columns? R, there's only one r. R is the easy one. Which column is the x?
J.
Column J, exactly, because column L is now gone. Okay, we are back to column J now. So column J has a value of 1. 1 times R, which is 1, is also 1. We store that back to column, global variable R, which is column D. After line 7, we get out of the conditional statement. We go to line 11. Once again, 2 tasks to perform. The return line number is in column I. It tells us to continue execution on line 7. And then the second thing we have to do is to deallocate the 2 columns. And oops, wrong place to put it. Put it here. Now we're back onto line 7. But column I, J, K, and L are all deallocated. So if I want to figure out what I need to do next, I will have to refer back to column G and column H. So we can expose those a little bit here and then scroll the bottom up. Now, when you do your homework assignment, you don't have to deal with it like this. Why not? Hmm? Well, because you have a bigger screen to begin with. This is only at 1024 by 768. I don't think any one of you are still using a small screen like that. No. Okay, a netbook may still have a screen with this type of resolution, but I hope you're doing your homework assignment on something that has a bigger screen. The other thing is, I don't think you need to magnify the screen to 170% just to see what you're doing. I have to do it in the class, so that people in the back can see the text a little bit more clearly. Okay, we're back onto line 7. Line 7 is still doing the same thing. We want to compute the product of r and x. But when we look it up, we only have column H now, as column H and column F are the only 2 x's left. But we always refer to the one on the right-hand side. So the rightmost definition of x is column H, and it should have a value now. It has a value of 2. So we are multiplying 2 to 1 and then storing the product of 2 back into global variable r. And then we can continue on to line 11, which means we look up the return line number, we continue execution on line 7, and then we deallocate the 2 columns, one for the return line number and one for the local variable x. Now we are back onto line 7. I have to scroll this side just one more time. Line 7 wants to compute the product of r and x. X this time is column F, r is column D. 3 times 2 is 6. We store 6 into global variable r. And then we look up the return line number. It tells us we have to return to post. Then we go ahead and deallocate both of those columns, continue execution at post, and the entire algorithm has completed. It looks really awkward and looks complicated when you look at it like this. Let me take away all those individual scroll panels. You just have to drag it out of your screen to make it one big blob again. And I can decrease the zoom so you can see the shape of the whole thing. Does that look familiar to you? It looks almost the same thing as last time, except this time we also have columns for our local variables. Are there any questions at this point about this trace? No questions? Okay. Okay, so we want to eliminate the use of global variables step by step. Which one should I target next? Because we still have two global variables. The one is R and one is N. Which one do you think I should eliminate first? R is actually the hard one to eliminate. N is the easy one. Okay, so we are moving on from the concept of a local variable now onto the concept of a parameter. Okay, the concept of a local variable is very simple. If you look at this algorithm here, local x means nobody really cares about the value of x. Only when I'm inside this subroutine from line 2 to line 10 that I really need to use the variable x. A parameter, on the other hand, means I would be able to pass values into a subroutine. Okay. So we'll go ahead and take a look at the mechanism of a pass by value parameter, and then we'll go ahead and see if I can simplify this program by the use of a parameter. So we'll go ahead and make a new spreadsheet. And I'll define a new subroutine, and I'll just call this subroutine increase, okay, because that's all it's going to do. And this time we have a construct called by val, okay. Well, this is a new thing, we haven't seen this before. And I'll just say, n is a by val parameter, which is by value, by the way. X gets x plus n, and define sub. X, which is a global variable, gets a value of, let's say, 15 to begin with. I'm going to invoke the subroutine increase, but I also have to specify the value of n. So in this case, let me just specify the value of n as 7. So 7 is the initial value of n, and that's my program. So let me bump up the magnification. Before we trace this program, let me describe what a parameter is, particularly what is a by value parameter. Because the name doesn't really tell you anything about it, doesn't really tell you any attributes or properties or characteristics of a parameter. Need to resize this screen a little bit. But when we trace it, it'll be very clear. A by value parameter has two important characteristics. One, it is almost like a local variable. In other words, we allocate when we invoke a subroutine, and we deallocate when we get out of a subroutine, just like with a local variable. The second point is, unlike a local variable, which always starts with an unknown value to begin with, a by value parameter starts with a value. And not only that, that value is specified by the invoke statement. Okay, so let me just repeat those 2 points, and we'll see from the trace, when we perform the trace, we'll look at those 2 points again. Point 1, it's almost like a local variable. The allocation and the deallocation is exactly like a local variable. Point 2, unlike a local variable, it doesn't start with an unknown value. It starts with an initial value specified by the invoke statement. So those are the two things we have to watch out for when we execute this code. All right, so we start with these two columns because x is still global. And we'll give it an unknown here, a pre. So the precondition of x is we don't know its value. And then we start execution on line 5 because it is the first line outside of the definition of a subroutine. Line 5 initializes x to 15. And then we go to line 6. It is an invocation of the subroutine. This part is standard, okay? We have to remember where to go back to when the subroutine is done, so the return line number part is standard. The second part is, what do we do with n? Remember what I said a little bit earlier? A bi-val parameter is almost just like a local variable. What do we do with local variable at this point of execution? We allocate a column, right? So this means, for bi-val or bi-value parameters, we do exactly the same thing. We allocate a column when we get into the subroutine. But unlike a local variable, we don't say that it is unknown to begin with, because the invoke statement is going to specify the initial value of n. What do you think n should start with? 7. Exactly. So when we get into the subroutine on line 3, when we need to add x and n together, x is column B, it has a value of 15. N is column D, it has a value of 7. 15 plus 7 is 22. We store 22 back into x, which is a global variable. So column B is now updated to a value of 22. And then on line 4, we have to do two things. One is to figure out where to go back to, which is post. The second thing we have to do is to deallocate something. But just like a local variable, you also have to deallocate bi-value parameters. So we just go ahead and do the same thing as before, strike it out to indicate that both of these columns are gone. Are we doing okay so far with the concept of bi-value parameters? Once we understand local variables, this one is fairly easy to understand because there's only one difference. One starts with an unknown value, one starts with a value specified by the invoke statement. What do you think, what is the role of bi-value parameters? Why do you think it is helpful? You can give it certain things to process, right? You can say, oh, I want to add this number to this number. You can specify things. It is the in tray of an office. A bi-value parameter serves as the in tray of an office. It's not an out tray. You cannot get anything out of a subroutine using bi-value parameters, but you can use it as an in tray to tell a subroutine, okay, I want you to process this. This is the input. It's an in tray. Let me save this program. And we have enough time to revisit our recursive factorial program to make use of bi-value parameters. So we'll call this, I'll just call it bi-val. And we're coming back to factorial. But this time I'll save the program again, but using a different name, factorial using bi-val parameters. And it is considerably easier this time, because instead of using local x, I'm going to change this to bi-val, and I would use both. I would use bi-val n to replace variable x and variable n in the previous program. So line 3 is no longer necessary. This is this I can delete. This I only have n, so x doesn't exist anymore. I don't need line 5 anymore. I get rid of line 5. I still need line 7, but when we invoke f, now that we have a bi-val parameter, we have to specify what is the initial value of n. This is the really confusing part, because the new value of n is n minus 1. So we'll take a look at this when we get to that point. We don't need line 12 anymore. Delete that.
7 as well.
Sorry?
Line 7.
Line 7.
There's no x.
Oh, we have to replace it with n. See, okay. So we'll go ahead and replace this x with n. I think the program got shorter. It got shorter, and we also eliminated the use of one global variable. Because n was global, and we don't have n anymore. In fact, we also stopped using the local variable x. So we kind of combined, it's a nicer program now because it's shorter. It's also a little bit more concise, and it doesn't have as many global variables. It only has one global variable left. I think we got enough time to trace it, so we'll go ahead and trace this algorithm. I'm going to remove this entire sheet because I have to make so much changes. It doesn't really make sense to reuse it. Comments, line number, and a single global variable r in this case. The precondition is we don't need to know anything about r, so put a question mark here. And then we can proceed with the rest of the program. Starting with line 10. Line 10 is an invocation, so we have to do the usual thing, reserve a column for return line number, but we also have a by-val parameter, n, so we have to reserve another column for n. The return line number is posed because this is the last line. N has a value of 3 because it's quite obvious because we use 3 to specify parameter n. So that part is fairly simple. And then we continue execution inside the subroutine, starting from line 3. Line 3 is, it's a lot easier this time because n is greater than 0 is true because n has a value of 3 right now. And then we go to line 4. Line 4 is the sticky point at this point because line 4, the first part of line 4 is easy. The return line number is line 5 because when we come back we have to continue execution on line 5. This part is kind of easy too. We know that we have to allocate a new column for parameter n. The question is, how should I specify this value? In other words, on line 4 of the algorithm, I use n minus 1 to specify the value of n, which seems to be kind of tricky. What do you think? The n minus 1, which n should I use with the n minus 1 part of the invocation?
The one this one is, or the first one?
The only one that makes sense is column E, right? Because column G is trying to guess its value. If I want to calculate n minus 1, I have to use column E. Is that making any sense? Because I have not switched to use column F and column G right now. I'm still setting up the columns. So the n of the n minus 1 is referring to column E, which is 3. 3 minus 1 is 2. That value of 2 is used to specify column G. Are we doing okay so far? Is that okay? Because this is the only tricky part of this algorithm. The rest is actually easier than last time. Now that we have set up the return line number and also the parameter, we can continue execution in the subroutine, starting on line 3. N is greater than 0 is still true. Then we go to line 4. It's the same thing. Set up a column for return line number. Set up a column for n. The return line number is line 5 because the invocation is on line 4. This time, n minus 1 is using the n, which is column G. 2 minus 1 is 1. So column I is now initialized to a value of 1. Is that okay? It's basically the same thing as last time. It's just repeating a few times here. We go back to line 3. N is greater than 0 is still true for the last time. And then we go to line 4. We have to do the invocation again. The return line number is line 5. The n of the n minus 1 is referring to I, column I, which has a value of 1. 1 minus 1 is 0. So the new n has a value of 0. Then we continue execution on line 3. N is greater than 0 is now false. We have no choice but to go to line 7. Line 7 initializes R to 1. And then we get out of the conditional statement. We get to line 9, which is the end of the subroutine. Two things to do. Look up the return line number. Tells us that we have to continue execution on line 5. Then we can deallocate both of these columns. Now we're back onto line 5. Line 5 wants to compute the product of R and N. What do you think? Which column and which two columns should I multiply?
I see.
Column C and column I. Okay. Column C has a value of 1. Column I has a value of 1. 1 times 1 is 1. After line 5, we get out of the conditional statement. We get to the end of the subroutine on line 9. Once again, we have two things to do. Continue execution on line 5 and deallocate those two columns. Now we're back onto line 5. Once again, we want to compute the product of R and N. R is easy. It's a global variable. It's always column C. N is a bi-val parameter. I is now gone, so the next one available is G. G has a value of 2. Column G has a value of 2. 2 times 1 is 2. We store that back into R. We get out to line 9. Repeat the same thing. Look up column F. It tells us to continue execution on line 5. Deallocate those two columns. Continue execution on line 5. Line 5 wants to multiply R and N. N this time refers to column E, which has a value of 3. R, which is a global variable, has a value of 2. 2 times 3 is 6. We go to line 9 again. This tells us to continue execution at post. And then it's time to deallocate both columns. And then we continue at post, which means we're done. We're at the end of the execution. Do you think this version is a little bit better than the one that we talked about earlier?
Yeah.
So next time on Tuesday, so you have to read ahead of me a little bit. On Tuesday, we'll talk about passing by reference, okay, which is one mechanism of passing a result out of a subroutine. Because your bi-value parameters cannot do that, okay, because it's not available anymore back to the invoke statement. So read ahead of me, read passing by reference. We'll talk about that on Tuesday. And now you guys can get your coffee and soft drink and whatnot.